Man, I have to work on this project for school about Newton's 3 laws. But it's such a nice day. I think I'll take a nap. Ow. Well, I guess that was Newt reminding me to do my project. And wasn't that one of his laws? Any two given objects exert a gravitational force of attraction on each other. Let's see. This project is supposed to be about Sir Isaac Newton's 3 laws of motion. The first one was the law of inertia. What exactly did Sir Isaac Newton say? I've developed 3 laws of motion. My first law is the law of inertia. It can be proven that an object at rest will stay at rest unless acted upon by a force. Or stated another way, an object moving in a straight line will continue to move in a straight line unless acted upon by another force. Hey, I get that. It's like when the Florida Gators are playing football. Tebow throws that ball to Riley Cooper or Deontay Thompson. Once Tebow throws it, the football continues moving in a straight line until the receiver catches it for a touchdown. Oh my! Of course, when my friends and I play, a lot of times it's different. I throw the ball and it doesn't go far enough and it falls to the ground incomplete. That's another example of the law of inertia because the other force acting on the football is the Earth's gravitational pull. This report is a lot of work. I better take a little break and go get a snack. This is also like Newton's law of inertia. I put a snack in here a couple hours ago, and it's still there. Wait, half of it's gone. Well, you know what Newton says, an object at rest will stay at rest unless acted upon by a force. In this case, a person. Athena! Okay. I haven't gotten very far on this project. I need another example of Newton's law of inertia. What could it be? Oh hey, that's it. This pen is an example. I mean, this report isn't going to write itself. In fact, it hasn't done one bit of work while I've been away. So that's it. A pen left at rest here on my desk is going to stay at rest, at least until I come back and pick it up. Now that I have my examples for the first law of motion, I better finish one more section before I head out to practice. And that's about Newton's second law of motion. The speed of an object moves once a force has been exerted on it can be determined by the amount of the force and the mass of the object. The inverse is also true. One can also figure the force exerted on an object by multiplying the mass of the object times the acceleration of the object. Why do I keep hearing all these voices? I better head out to the basketball courts. Shooting a basketball is a good example of Newton's second law of motion. Too less force, air ball, too much force, and it bounces off the rim. But with just the right amount of force, score! Now that practice is over, it's time to head to the grocery store. I gotta remember to include this in my project. Pushing this cart is a lot like Newton's second law of motion. Remember, Apollo, force equals mass times acceleration. Now that's weird. The more stuff I put in, the heavier the cart gets, and the more force I need to push the cart at the same speed. Whee! My hand hurts. This pen is getting heavy. This pen is getting heavy. Newton's law doesn't apply, but one thing's for sure. I better accelerate this project or else Dad is going to come in here and apply some force on me. I finally made it to Newton's third law of motion. I think I remember what that's about. Let's see. Sir Isaac Newton said that for every sister, there is an equal and opposite person. I most certainly did not. Apollo, what I said was, for every action, there is an equal and opposite reaction. Oh yeah, that's it. For every action, there's an equal and opposite reaction. That's kind of like arm wrestling. One hand pushes the other. For as much as one pushes, the other one moves, and vice versa. When both hands are locked in the middle, that's balanced, and total force is zero. When one guy wins, that's because the force became unbalanced one way or the other. It's also like when I'm playing tug of war with my friends. Both sides are pulling against each other. At first, when both sides are pulling and the rope isn't going in either direction, that's balanced force and total force is zero. But when one team pulls the other team over, the force becomes unbalanced. Either way, balanced or unbalanced, a tug of war match is a clear example of Newton's third law of motion. Well, Apollo, that's not exactly what I had in mind, but I guess you could think of it that way. I guess even taking a bite out of this apple is like Newton's third law. Sticking your teeth in the apple is the action, and ripping a piece off is the reaction. Guess all that hard work paid off. You're welcome, Apollo.